In this video, we're going to learn how to check if a number is an Armstrong number using C++. So an Armstrong number is an integer with a special property. The sum of each digit in the integer taken to the power of the number of digits in the integer is equal to the integer itself. So for example, if we have 153, this is an Armstrong number because this number has the digits 1, 5, and 3. And this number has 3 digits total. So if we take each digit and raise it to the power of 3, and then we take these numbers and add them together, we'll get 153 because 1 to the power of 3 is going to be 1. So we'll have 153 is equal to 1 plus, and we'll have that 5 to the power of 3 is 125, and 3 to the power of 3 is 27. So 1 plus 125 plus 27 is equal to 153. And so because the number has this property, we say it's an Armstrong number. So in order to determine if a number is an Armstrong number, we'll need to determine the number of digits in the number. We'll also need to identify each individual digit in the number. We can use division operations to achieve this, because if we have 153 and we divide this number by 10, we'll get here 15 remainder 3. Then if we take the quotient of the last division operation and continue to divide by 10, we'll get here 15 divided by 10 is equal to 1 remainder 5. Then if we take this quotient and divide by 10, we'll get 1 divided by 10 is equal to 0 remainder 1. And this series of division operations here gives us all the information we need, because here we have each digit in the number as a remainder of a division operation, and the total number of division operations gives us the number of digits in the number. Now in C++, we can do integer division with this division operator here. That's going to give us the quotient of a division between two integers. So we'll get these numbers here. And the modulus operator is %. This will give us the remainder of division between two integers. So we can use this operator here to get each digit in the number. Let's first implement a function in C++ to count the number of digits in a number. We'll have here int count digits, and this function is going to accept an integer as an argument. So we'll have here int number. Then we'll supply a definition of this function down here. So we'll copy this and paste it down here. And what this function will do is continually divide the number by 10 until the number is equal to 0. It's going to keep a count of how many divisions this takes, and that's going to tell us how many digits are in the number. So first, we'll declare an int variable called digits, and we'll assign 0 to this variable. This is going to be our running count of digits in the number. Then we'll have a while loop that's going to continue so long as the number doesn't equal 0 yet. Each time in the while loop body, we'll take the number and divide it by 10 and assign the result back into number to follow this process here of continually dividing the quotient of the last division operation by 10 until the number is equal to 0. We'll also increment digits each time this while loop body runs to keep track of how many digits are in the number. Then when the loop stops because the number does equal 0, we'll have counted the number of digits in the number, and we can return digits to return that count. Next, we'll declare a function to check if a number is an Armstrong number or not. We'll have here bool for the return type, because the function is going to return true if the number is an Armstrong number and false otherwise. We'll call the function isArmstrong, and the function is going to accept an int as an argument. So again, we'll have the parameter int number. Now the first thing this function will do is call count digits to determine the number of digits in the number. Then after that, this function is going to follow a similar process to count digits, where we'll take the number and divide the number by 10 continuously until the number is equal to 0. But this time, We'll also use the modulus operator to extract each digit from the number. So down here, we'll define this function. We'll have bool is Armstrong int number. And the first thing we'll do is call count digits. So we'll have here int total digits to declare an int variable called total digits, and we'll assign to this variable the return value of calling count digits when it's passed our number. So this function is going to return the total number of digits in the number, and we'll assign that to this variable here. Next, we'll declare a variable called sum of type int. We'll initialize this variable to 0. Sum is going to store the running sum of each digit in the number taken to the power of total digits. Then we'll also declare a variable called temp. We'll have here int temp, and we'll assign to temp number. So at the end of this function, we're going to compare the sum of each digit in the number taken to the power of the total number of digits in the number to the number. And if those values are equal, that means the number is an Armstrong number. If they're not, it's not. The problem is this process of continually dividing the number by 10 is going to modify the original number. So what we do is we make a copy of the number here. Temp is going to be a copy of the original number here. Then we can have a while loop that goes through this process using the temp variable. So we'll have while temp doesn't equal 0, and each time in this loop body, we'll take temp and divide it by 10 and store the result back into 10. But this time, we'll also extract each digit in the number. We'll have here int digit is equal to temp modulus 10, where modulus 10 is going to give us the remainder of dividing temp by 10. That's going to extract the next digit in the number. Then we need to raise this digit to the power of total digits. Now in C++, there are built-in power functions. These functions, though, are intended to work with floating point numbers, and there can be issues sometimes when using integers with these functions. So we'll make our own power function. Up here, we'll declare a function called power. The return type is going to be int, and the function is going to accept two int values as arguments. So we'll have the parameters int x and int y, and the function is going to return x to the power of y. We'll copy this and supply a definition of this function down here. And we'll start off by declaring a variable int result and assigning 1 to this variable. And we want result to store x to the power of y. So if x is 3 and y is 4, then result should be 3 times 3 times 3 times 3. So what we'll do is make a loop that's going to run y number of times. And each time in the loop, what we'll do is multiply result by x and store the result back into result. So we'll have a for loop. We'll have for int I is equal to 0, I is less than y, and I++. So this loop is going to run y number of times because I is going from 0 up until, but not including y, by 1. Each time, we're going to multiply result by x and store the result back into result. Then down here, we can return result. So we're going to have return result. Then in our isArmstrong function, we can now use our power function. So we'll have sum plus equals the power of the digit we extracted to the power of the total number of digits in the number. Then once the sum is calculated, we'll compare the sum to the original number. So if the sum is equal to the number, we're going to return true. Otherwise, we're going to return false. We can now test our function out. So up here, we'll call isArmstrong. We'll have if isArmstrong returns true when it's past 153, then we'll output here 153 is an Armstrong number, followed by an end line. And now we'll test our program out. So we'll save, compile, and run our program. And we'll get that 153 is an Armstrong number, which is correct. So this is how we can check if a number is an Armstrong number using C++. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.